University of Castilla-La Mancha and also from the Albacete Research Institute of Informatics in Spain. This work is motivated by the high impact that the Internet of Things is having in many industries, such as energy, transportation, or manufacturing. But still, the potential of IoT technologies for remanufacturing has to be explored. Of course, there are many well-known benefits of the IoT in remanufacturing, such as the reduction of uncertainties or an improved cooperation between stakeholders. But to date, there's a huge gap to be filled because there are very, very little practical IoT approaches for remanufacturing in the literature. This work has three main aims. The first one is to identify the technical barriers to remanufacturing, then to explore which are the use cases of IoT in the literature, and finally to identify existing gaps and future research directions in these areas. For this, we conducted a rapid literature review, and for this we selected a very highly focused search target, in this case the intersection between IoT and remanufacturing. And with this, we have three main contributions, which are a brief literature review regarding IoT and remanufacturing, a mapping of the use cases in these two areas, and finally an analysis and discussion to identify the future research challenges. With the cost-effect analysis, we identified some of the barriers to remanufacturing that could be addressed with the use of Internet of Things technologies. And these are, the first one is the information availability, because we all know that there's nowadays a lack of original design specifications, but also there's a lack of waste information of products. The thing is that there's also a high diversity of parts, and this is the so-called big data problem. And this is something that needs, of course, to be addressed. Then there are increased uncertainties. We don't know which is the quality condition of the parts, but we also don't know which are the recovery or the arrival rates of materials. And then the lack of legislation, it's what makes most customers lose their trust on remanufactured products. Of course, the operational costs are quite high. As I said, there's a high diversity of parts, but also the lot sizes are very small. So this could be addressed with the Internet of Things, or at least enhanced. And finally, there's a lack of communication. There's a lack of feedback from remanufacturers to designers, but also cooperation between manufacturers and remanufacturers. So these 5 reasons or barriers to remanufacturing could be addressed with the Internet of Things. Based on the recent study from the literature that reviewed the IoT capabilities in remanufacturing, we selected here 4 of them that, from our point of view, are closer to a practical point of view. So the first one is the ability to get the product's information, then to do over-the-air software updates to a product, to provide and to give feedback from remanufacturers, and finally, the ability to develop goal-based algorithms. So what we did here is to propose 3 functional groups, which are product lifecycle management, end-of-life management, and end-to-end approaches. So out of approximately 35 works that were analyzed from the literature, after filtering the duplications, we removed these works that we believe that are not as close as we would like to both areas, IoT and remanufacturing, and we ended up with 13 works that were classified in these 3 areas. In the first area, we have 5 works, and the 2 first works focused on product lifecycle monitoring using the Internet of Things. In this case, they were using RFID technology. Then we have the 2 next works, which focus in this case not in communications, but in the use of sensors. In the first case, to improve remanufacturing efficiency, and in the second, they focus on how sensors can improve, how can they influence the cost warranty. And finally, we believe that this work was very interesting in the literature because the 4 previous works didn't provide a practical approach, and this one provided an architecture for the Internet of Things in this area. And they provided a remanufacturing scenario using automated guided vehicles where they focused on both sensors and communications. In this case, apart from RFID, they use also TCP/IP communications. Regarding end-of-life contributions, the first two works focus on the monitoring of solid waste using Wi-Fi and RFID technologies. And the last work was about how RFID can increase the recycling rates of products, in this case, cell phones. Regarding end-to-end approaches, we analyzed 5 works. The first one was about the design of a sensor-based positioning system relying on Wi-Fi and RFID technologies. The second one was about how an IoT architecture could improve the remanufacturing of automobile engines in this case. And the authors assumed that there was real-time communication, and this was the input to a simulated case study. And they compared the traditional one with the IoT enabled. Then there is a cross-case analysis showing the potential of IoT improving feedback channels, and a Recycling 4.0 framework where the authors provided a literature review focusing on the benefits of different Industry 4.0 technologies for remanufacturing, in this case, including also IoT. Finally, this contribution is from ourselves from some months ago, and we did this contribution because we thought that there was a lack of works focusing on the communications perspective of the IoT in remanufacturing. So we presented an IoT-based framework, in this case for the recovery of electric vehicle batteries, and we provided an in-depth qualitative analysis of different IoT communication standards. In this case, as there are very little practical approaches in the literature, we'd like to show here an example of what we are working in nowadays with a contribution from the literature. And this was an end-to-end architecture for reverse logistics in this case, where we define different stages like identification, inspection, and classification of parts and products at their end of life. So we use here RFID, but also Bluetooth Low Energy technologies using masters, slaves, beacons, and scanners in the case of Bluetooth. And we also designed this kind of smart containers where we used load cells to monitor the inventory of reusable parts. This information was managed from the so-called hybrid gateway, and we defined 2 separate information flows. The first one using the LoRaWAN network, including the context information of the products, and the second one was using MQTT over Wi-Fi to update in the Amazon Web Services the inventory of reusable parts in real time. As conclusions of this work, we'd like to highlight that IoT is the pillar for both acquisition and transmission of this information about a product. And of course, there are many benefits. We could have real-time inventory management. We can have higher transparency and also less uncertainties. And a good thing is that the technology life cycle is longer than the life cycle of a product. However, there are certain gaps in the literature. From our point of view, typically the IoT is referred to as RFID communications. And we'd like to highlight that the IoT is growing so much, it's growing so fast, and there are many available communication standards. So we should not be limited to RFID, which we all agree it's very useful, but also explore different communication standards that might fit better for different use cases. There's a lack of practical IoT deployments in this domain. And what happens is that practically the 90% of times, authors assume that fast real-time communication is possible. But we want to focus on the fact that it's important to deploy this communication based on IoT standards, because it could be a bottleneck for other Industry 4.0 technologies, such as big data, artificial intelligence, or even the digital twin. Finally, as open research challenges, we point to the design of mechanisms for this recovery of IoT devices, which of course will be a problem. We need to recover these microcontroller-based boards. And also we need to face the interference issues that nowadays happen with antennas and metallic surfaces. Finally, of course, we need to deploy end-to-end architectures in the remanufacturing context because this is a huge gap nowadays in the literature. And to finish, of course, IoT has specific communication challenges to be addressed. And these are the scalability, security, latency, reliability of communications, and power consumption. So thank you so much for your attention and feel free to ask any question.